Open your book to page 421. Today's lesson is on complex numbers in rectangular and polar form. This is very similar to the coordinates that we did in the previous lesson. And so on page 421, a complex number is in the form of a plus bi form. So for example, the complex number z will equal to x plus y I. So this is the real part and this is the imaginary part. And if you go down a little bit on page 421, if you look right in the middle of that, so for a point, for a single point or points, the rectangular form would be x, y, and the polar form would be r theta. Now for complex numbers, the rectangular form would be x plus y I. So again, very similar. This is in the coordinate form and this is in the complex number form. And for this one, you're going to get r times e to the I theta. So this is just the form. So basically you have the radius and the angle. Again, very similar. Now let's go ahead and look at some examples. Let's go to page 422 and example 1. It says plot each complex number in a complex plane. So A, you got 3 plus 4i. So when you plot that, okay, so 3 plus 4i, so you go 3 in the x direction, so from here you go 1, 2, 3, and then 4 in the y. So I is the y direction, so 1, 2, 3, 4. So you go, so it'd be right over here, right? So you go 3 this way, 4 this way, right? See over here. So because this is a polar graph, so it's harder to graph the rectangular on a polar graph. Now if you go to B, you have a 5e to the I, 3 pi over 4. Again, the I is just part of the form, okay? So you can just ignore that. So basically just show you that the angle is 3 pi over 4. So if you go 3 pi over 4, so 1, 2, 3. So here's your 3 pi over 4, right? And the radius is 5, so you go 1, 2, 3, 4, 5, and you get this right over here. So this is point A. Again, you go 3, 4. Over here, you go radius of 3 pi over 4 and the radius of 5. So this is your point B. And you go point C is negative 2. So this is like a negative 2, 0. So you just go negative 2, so 1, 2. And that's it. So this is point C. And for point D, you get 4e to the I negative pi over 2. So over here, the angle is negative pi over 2, so you come this way. So this is negative pi over 2 over here. Right, the angle, negative pi over 2, and radius is 4. So 1, 2, 3, 4. And so this point would be right over here. So again, the complex number are not a difficult once you kind of able to relate. Okay? And if you go to page 423, and right in the middle, again, we see this relationship before, right? So that's a relationship between the rectangular and the polar form. Now there are a couple of terminology you should be familiar with. Okay, one is called modulus. Modulus or absolute value is the length or the r. The argument or angle is the theta. So be familiar with the term modulus and argument. So argument is the angle and the modulus is the length. Okay. Now let's go to example 2 on page 424 to see how to convert from one to the other. So page 424, example 2, A, you have z1 equal to negative 1 plus I, and you want to in the polar form. So just like what you did before, so draw your triangle. So negative 1 I, right? Again, I just give you the direction. This is the real and this is the I. So negative 1 and one I means go one in the y direction. So from here you can figure your radius, use your Pythagorean theorem. So it'd be square root of 2, and the theta would be 3 pi over 4. So that means Z1 in the polar form would be, the radius would be square root of 2, and the angle is 3 pi over 4, so it would be e to the I 3 pi over 4. Okay, so again, that's the rectangular form, and this is the polar form. The polar form, here's your radius, here's your angle. Okay, now let's go to B. Z2 equal to 1 plus square root of 3i. Again, you draw your triangle. So that's 1 square root of 3. So 1 square root of 3. And so radius would be 2, and this would be pi over 3. So Z2 would be equal to 2 e to the I parentheses pi over 3. Okay, so again, here's your radius, here's your theta. Okay, R and theta, and that's it. So again, very similar to what we did earlier with the coordinates. Now let's go to C. You have Z3 equal to negative 3 minus 7i. So you got negative 3, negative 7, negative 3, negative 7. So from here you use Pythagorean theorem. Use a squared plus b squared and take the square root. And so you're going to get so when you do that, you get 7.62, and the angle theta. So from here you have to, so tangent theta equal to negative 7 over negative 3, and so theta is equal to, now the angle that you get from the calculator, it will give you this angle over here. So to get this angle, you have to plus pi. Okay, so you're going to get, so once you calculate, you're going to get negative 1.98. And so this becomes, so Z3 will give you, the radius is 7.62 e to the I, and the angle is negative 1.98. Now this is radian, right? So just be aware of that, and that's it. Okay. Now let's go to example 3. Example 3 is kind of going the other way. They give you in the polar form, you have to get in rectangular form. So A, you have Z1 equals square root of 2 e to the negative pi over 4i. Okay. So again, what you want to do, you want to draw the picture, draw the triangle. So this is the angle is negative pi over 4, so it's down over here. Radius is square root of 2, so this is 1, and this would be negative 1. So by looking at that, your Z1 would be equal to 1 minus I, right? 1 minus I, and that's it. Okay. Now you go to B, you have Z2 equal to 3 e to the 120 degrees I. You can draw 120 degrees is right over here, and the radius is 3, and therefore this would be 3 over 2. This would be 3 square root of 3 over 2. Use your 30-60 spatial triangle, and this would be a negative. So Z2 will equal to negative 3 over 2 plus 3 square root of 2 over 2i. Okay, and that's it for Z2. Now when you go to C, you have Z3 equal to negative 5 minus 2i. No, back up, wrong. So Z3 equal to 6.49 e to the negative 2.08 I. So negative 2 radian, so this is negative pi over 2, it's about 1.5. And so negative 2 radian is about right over here. And so when you draw, and this is 6.49, and this is negative, so theta equal to negative 2.08 radian. So now what you need to do is you need to go and use the sine and cosine. Okay, so the x over here, so x will equal to r cosine theta, right? So x will equal to 6.49 cosine of negative 2.08, and then you work it out, and y will equal to r sine theta, right? And just substitute and you work it out, and so z3 will equal to negative 3.16 minus 5.67i. So you can use your r cosine theta, r sine theta to figure out the x and figure out the y, and you put it, so that's your x and the y. Okay, now next, let's go to page 426. So here are important rules to multiply and divide in the Porter form. Okay. And again, this is just like a regular algebra exponents. So you just use the law of exponents, the product rules, and the quotient rule, just like regular algebra, and you would be fine. Okay. Now just be aware of if you look on the very bottom here, on here, another common way of writing the Porter form is called a CIS form. So if you look on the bottom of page 426, okay, so if you have Z1 equal to R1 e to the I theta, right? Another way of writing this, you're going to see this quite often, is this is equal to R1 times cosine of I theta, cosine of theta so this, another way you can see this quite often is this right over here, cosine theta plus I sine of theta. Okay, so another way of writing this is this. So sometimes you can see it written this way, and abbreviation for that is R CIS theta. So C is cosine, I is the I, S is the sine. So sometimes you can see written in this one. Just be familiar with it when you come across, then you know that this is that, this is that. Okay, so a lot of time again you're gonna see this cosine theta plus I sine theta, or more commonly CIS theta, but they are the same. Okay, so you can, if you're comfortable with this, you can convert back. Okay, now let's go to example 4 of how to calculate. So example 4a. Okay, so you got Z1 equal to 8 e to the 50 degree I, and Z2 equal to 4 e to the 30 degree I. So A, you're looking for Z1 times Z2. So when you multiply circuit, you just apply the product rule, right? So 8 times 4 is 32. Now when you times this, right, when you multiply, you add the exponent, right? So this will become e to the 80 degree I. Right? You just add the exponent, right? Just like product rule, right? And again, just to refresh your memory, for example, if you have like x to the 3 times x to the 5, right? When you multiply, what you do is the exponent. You add, right? So this is equal to x to the 8, right? You add the exponent. So same thing, right? So 50 degrees, when you multiply, in the exponent position, you add, so you give 80. Okay, and that's it. Okay, now if you go to B, you have Z1 divided by Z2. So when you divide, you're going to get 8 e to the 50 degrees I divided by 4 e to the 30 degrees I. And so this will give you, so 8 divided by 4 give you 2. And when you divide, you're going to get e to the, you subtract the exponent, so it'll be 20 degree I. Again, just like when you have an x to the 5 divided by x to the 3, right? You subtract the exponent, so you get x squared, right? So it's the same idea, okay? When you have exponents, when you divide, you subtract. Okay? And just a nice note, just a note on the bottom of page 427. That's the equation. You got e to the I pi plus 1 equal to 0. Now what's so significant about this equation is that it involves the 5 of the most important numbers in the history of mathematics. So 0, 1, e, I, pi. These are 5 most important numbers in mathematics, and they're all tying into one equation. Okay, now let's go to more examples. Let's go to page 428. And let's go and do some evens. Okay, so let's do number 24. So you have negative 1 plus I, 1 plus I, and you want to multiply this out using the Porter form. Now the Porter form is going to be very important, as we're going to see in the next lesson. Okay, but right now, you just need to be familiar with how to operate with the Porter form. So when you multiply, they want you to multiply using the Porter form. So what you need to do is convert into Porter form first. Okay. And then, so the first one is negative 1, 1, right? So negative 1, 1. So it'd be square root of 2. So this would be square root of 2 e to the, it's probably easier using the degrees. So this is 135 degrees, I, times, now second triangle is 1 plus I, right? So this would be square root of 2 e to the 45 degrees, I. Right? So again, this one is this one is this, and you do that. So now when you multiply, square root of 2 times square root of 2 will give you 2. When you multiply this, you add, so it'd be e to the 180 degrees I. And then they ask you to write the answer in the rectangular form and Porter form. Okay? And so this is the Porter form answer. Now to write the answer in the rectangular form, again, you draw your triangle again on this, right? So 180 degrees, and the radius is 2. So now when you look at a picture, the coordinate of that would be negative 2 plus 0 I, right? And therefore your answer would be just negative 2. Okay, it's because you don't need to have 0 I. And again, this is very powerful because if you go to number 28, okay, you have 1 minus I to the 3 power. Now, normally, you have to write it out 3 times and multiply, right? And the reason that Porter form is so powerful is that, especially with a high exponent, it's very easy to do it in the Porter form. Okay, so over here again, let's go and do this. So you can see how powerful the Porter form is. So you got 1 minus I, right? So you got 1, negative 1, so square root of 2. So this one you would get square root of 2 e to the negative 45 degrees I to the 3 power. So when you work these things out, okay, square root of 2 to the 3 power is square root of 2 times square root of 2 times square root of 2. This will give you 2 square root of 2. Right? Again, this to the 3 power. And this one, this is exponent of exponent, so become e to the negative 135 degree I. And now if you're going to convert back into the rectangular, so this is your Porter form. Now to convert to rectangular form, again, just draw your triangle. So negative 135 degrees is right over here. And the radius is 2 square root of 2. So this would be a negative 2, negative 2. So your answer in the rectangular form would be just negative 2 minus 2I. And that's it. So you can see how quick you can multiply instead of writing out 3 times and multiply individually. And just imagine what happens if you are like a 5 power or 10 power. It makes it even more difficult to multiply, right? But with Porter form, you can multiply very quickly. Okay, so this is the end of the lesson.